Limits to Infinity, Type 2. Today, we're going to continue our work with limits to infinity of rational functions. We'll encounter some radical notation, so we'll have to use the skills that we recently practiced about rewriting radical form in rational exponent form. Let's take a look at the first problem. Determine the following limit in simplest form. If the limit is infinite, state that the limit does not exist, dne. The limit as x approaches infinity of the cube root of 29 plus 27x to the sixth all over 10x squared plus 9x plus 1. So how do I go about solving this problem? I need to remember that, especially with rational functions, if I've got a limit as x approaches infinity, I only need to focus on the highest powered or the highest growing term of each group. The group on top, well, the highest growing term is going to be this 27x to the sixth. So I'm going to record that there, but that's not all that touches it. I still have this cube root that's involved. So I'm going to keep the cube root as well. In the denominator, the highest growing term is this 10x squared, and I'll record that. Okay, I should simplify this a little bit so it's easier to read. Cube root of 27x to the sixth. Well, the cube root of 27 is just 3. Cube root of x to the sixth, now doesn't that just mean x to the 6 divided by 3? Yeah, when we have this index here, this root, we can put that as the denominator of the exponent, keeping the original exponent in the numerator. X to the 6 thirds, well, more simply said, that's just x squared. The denominator of our main function hasn't changed at all, so I'm going to leave that as 10x squared. Okay, now let's use one of these shortcuts. Are we dealing with the same degree on top and bottom, or higher degree, or on top or on bottom? Well, we've got the same degree, x squared in both situations. So if the numerator and denominator have the same degree, the limit is a fraction, the n coefficient over the d coefficient. That's just 3 over 10. Can I simplify that? No, that's as simple as that fraction gets, so that's my final answer, 3 over 10. Good. Let's take a look at another example. Once again, we're determining the limit in simplest form, and we have a new limit expression. The limit as x approaches infinity of the cube root of 28x to the third plus 64x to the seventh minus 13, all over 4 plus 5x squared plus 2x. Once again, I'm going to focus on just the highest growing term in each group. On top, it's going to be this one over here, the 64x to the seventh, although all of that is under a cube root. So we'll include that as well. Down here on the bottom, it's just 5x squared. Okay, let's simplify this numerator a little bit. I can rewrite the cube root of 64 as just 4, and then the cube root of x to the seventh is x to the 7 over 3. And the denominator hasn't changed, it's just 5x squared. Okay, so which one of these is bigger? 7 thirds or 2, or are they the same value? Well, 6 thirds would be 2, so 7 thirds is a little bit bigger than 2. It looks like we have a numerator with a higher degree, and according to my notes, that means that the limit does not exist. It goes on towards infinity. That makes sense. If this number here keeps on getting bigger and bigger faster than this one down here, it's always going to keep growing. So my final answer here is D and E does not exist. Okay, let's take a look at one more problem. New problem, same instructions, new limit. Here we're trying to find the limit as x approaches infinity of the square root of 16x to the 7th plus 39x to the 4th minus 15 all over 6x to the 4th plus 4 plus 10x cubed. Again, I just need to focus on the highest growing term in each group. In the numerator, that's going to be this square root of 16x to the 7th. And in the denominator, it's just 6x to the 4th. And in the denominator, it's just 6x to the 4th. Okay, let's simplify what we have on top. Square root of 16 is just 4. And square root of x to the 7th. Now, when I had the cube root, I put a 3 in the denominator of this fraction, but I don't see a number here. Is it an invisible 1? Well, no. What do we call it? The square root. This invisible index is a 2, so we can say this is 4x to the 7 over 2. Perfect. Then we'll just have 6x to the 4th on bottom. Okay, which term is growing faster? Is it the numerator or the denominator? Well, look at the degree. X to the 7 halves is not as big as x to the 4th. 7 halves is just 3.5. So we've got the denominator with a higher degree, therefore we can assume that the limit approaches 0. It works. So to recap, for problems like these, we'll need to simplify in a few different ways. First, we only look at the leading term, the most powerful or the highest growing term in each group. Then we're going to need to use a little bit of simplifying strategies and rewriting radical notation. Then we compare our numerator and denominator. Do they have the same degree? Does the numerator have the higher degree, or does the denominator have the higher degree? You can make your decisions about your final answer based on that. Let me know what your questions are, and good luck.